Center for the Ethiopian Educational Information and Communication Technology presents Educational Satellite Television Programs.
Hello, teacher. Hello, students. Welcome to today's lesson about operations on complex numbers. In the last lesson, we learned how to add and subtract complex numbers. We also learned that the set of complex numbers is closed under additions, and that addition is commutative and associative. Today, we will study the multiplication and division of complex numbers. We are also going to learn about additive identity elements and additive inverses. Let us begin, students. Like we did last lesson, let us begin today by reminding ourselves how to multiply terms with variables. Here are two terms, students. Take a few moments to find their product, and we will check the answer together.
Students, let's get ready. Begin. Time's up. Let's get back to our lesson.
Welcome back, students. Multiplication of variables is very simple for you now, is it not? When we multiply x plus 3y times 2x minus 5y, it equals 2x squared minus 5xy plus 6xy minus 15y squared. This simplifies to 2x squared minus xy minus 15y squared. Well done. We can apply the same method when multiplying two complex numbers. if Z1 is expressed as the sum of x and y iota, and Z2 is expressed as the sum of a and b iota, then the product of Z1 and Z2 is given this way. The difference of ax and by plus the sum of bx and ay times iota. We do not need to memorize this definition, since we can treat complex numbers in the same manner as any other variable. We must simply remember that the iota squared is equal to -1, and use that fact to simplify the equation. We learned in the last lesson that the set of complex numbers is closed under addition. We also learned that addition of complex numbers is commutative and associative. The same is true of multiplication, students. When we multiply complex numbers, the result is a new complex number. Therefore, complex numbers are closed under multiplication. When we multiply two closed numbers, the order of the operands will not change the product, nor will the grouping of the terms. Therefore, multiplication of complex numbers is commutative and associative. Could there be even more properties for us to discover? Observe these three complex numbers. The definitions of Z1, Z2, and Z3 are the same as they were in the last lesson. Consider the following questions, students. Is the product of Z3 and the sum of Z1 and Z2 equal to the sum of Z1 times Z3 and Z2 times Z3? Is the product of Z1 and the sum of Z2 and Z3 equal to the sum of Z1 times Z2 and Z1 times Z3? What is the product of Z1 times 1? How about the product of 1 times Z1? Do your best to answer these questions. I will see you in a moment.
Students, let's get ready. Begin. Time's up! Let's get back to our lesson.
Hello again, everyone. In the first question, I am confident that you found the two products to be equal. In the second question, the product is equal to the sum. We can conclude from this that multiplication of complex numbers is distributive over addition. This means that if a complex number is multiplied by the sum of two others, the first number can be distributed to both of the other numbers and multiplied by each of them separately. In answering the third question, you found that both equations were equal to Z1. Therefore, the multiplicative identity of the set of complex numbers is 1. As you remember from the last lesson, when you use an operation to combine an identity with another number, that number stays the same. We will explore these ideas a bit further. Let Z1 equal 2 plus 3 iota. Let Z2 equal negative 3 minus 4 iota. Let Z3 equal 5 minus iota. Given these values, verify that Z1 times the sum of Z2 and Z3 is equal to the product of Z1 and Z2 plus the product of Z1 and Z3. You may begin.
Students, let's get ready. Begin. Time's up! Let's get back to our lesson.
Hello again. Let us see how you managed this activity. First, we calculate the product of Z1 and the sum of Z2 and Z3. We find that the product is 19 minus 4i. We then calculate the sum of Z1 times Z2 and Z1 times Z3. We find that the sum is also 19 minus 4i. Therefore, we have verified that the product of Z1 and the sum of Z2 and Z3 equal the sum of Z1 times Z2 and Z1 times Z3. Good work, students. You are doing well. Now, let us learn about division of complex numbers. We can treat division as the inverse process of multiplication. Provided b is not equal to 0, the phrase a divided by b can be symbolized as a times the inverse of b. What if we were to multiply x plus y iota by x minus y iota? The product is x squared plus xy iota minus xy iota plus y squared. This simplifies to x squared plus y squared. We can extrapolate even further. For any non-zero complex number, which we express this way, its multiplicative inverse is given by this formula. X over x squared plus y squared minus y over x squared plus y squared times iota. Make a note of this, everyone. Now, try out the formula for yourselves, students. Here is an equation involving two complex numbers. See if you can apply what you have learned to find the result. You can get started right away. Good luck.
Students, let's get ready. Begin. Time's up! Let's get back to our lesson.
Hello again. In order to solve this equation, we must find the multiplicative inverse of the divisor. As we see here, it is equal to iota plus 3 times 5 over 29 plus 2 iota over 29. Now we multiply each term. 5 iota over 29 plus 2 iota squared over 29 plus 15 over 29 plus 6 iota over 29. Since iota is the square root of -1, iota squared is equal to -1. Therefore, our final result is 13 over 29 plus 11 iota over 29. Did you find the same answer, students? Great work. That is all for today, students. We have learned about the multiplication and division of complex numbers, as well as the basic properties of multiplication. Great work today. Until next time, thank you, teacher. Thank you, students.